Carbon Exchange's webinar on understanding water management opportunities in your business. The webinar will be hosted by myself, Justin Decker. I'm an energy and water engineer working for GCX. I hope everyone can hear me loud and clear, and that the go-to webinar software is working for everyone. So yeah, let's get started. Okay, I'd like to just go over a brief summary of what we'll be covering today. We're going to start off with what is a water audit, then move on to flow measurement overview, the importance of a water flow diagram, importance of water quality measurement, what is a water management strategy, why your company needs a water management strategy concepts, good water practice policies, evaluating your options, and then just a brief slide on about what GCX is. And then at the end, we're going to move on to a question and answer session. Now, the webinar is set to run for approximately 45 minutes, where there will be then 15 minutes for questions at the end. So at any stage throughout the presentation, if you do have any questions, please just chat it. Just type it into your chat box as you think of them. We'll try to answer as many questions as possible at the end. And any unanswered questions will receive an email response a few days after the webinar. Right, so let's get started. I'd like to start off with defining the context of water auditing and the simple definitions to which the field of water auditing and water management is based around. Then we're going to move on to why companies should start to shift their thinking towards water management. So just to have a look at the definition of what water auditing actually is. Water auditing is a discipline concerned with quantifying water usage and water quality of a given set of boundaries. Now, there are two key points to take out of that definition, A being quantifying water usage, so how much water is used by the facility as a whole, and then to break it down to how much water is being used per water usage operation on the site. Then the second key thing to take out of this definition is water quality. When and where to measure water quality, and then hopefully where certain areas are identified that the water is of a high enough quality to use the output from one water usage point as an input to another water usage point. Now, a water audit also includes the concepts of water conservation and water use efficiency relative to the defined boundary. So now let's have a look at what each of those mean. So conservation is to use less water than the current usage. So if you look at a facility or site, that facility or site will have a water usage baseline, whether that's over a day, whether it's over a week, over a month, or over a year. It is the current trend of how the facility is using water. Now, to obviously conserve water would be to reduce from that water baseline. You'll go about that by obviously setting targets and then developing what we call a water management strategy. Through the implementation of some of the water management opportunities, out of the water management saving, you would hopefully then achieve a reduction in water use and hence conserve on the water. Then on the efficiency side, efficiency is to use the same amount of water to do more work. Now let's just have a look at that, what we're actually implying there. For instance, if you have a shower and a person normally uses the shower, most of the water then goes into the drain plug at the bottom of the shower and back into the sewers. Now, a possible water management opportunity would be to install a grey water harvesting unit, which would then take that water leaving the drain plug of your shower and capture it and then possibly use it as an input to another operation, such as irrigating your garden system. So now in this instance, the same amount of water which you would normally use in your facility is now being used for two operations rather than the traditional ones, and hence the water is doing more work. Okay, so now we're just going to go through some of the basic definitions. I've thrown out a few words there, namely inputs, operations, and outputs. We're going to have a look at what each of those actually mean and what the different sources are. So input water. Input water can be water that enters either the whole domain to be audited or only entering a specific or several operations. Now let me give you an example of what the input water would be. Well, for 98% of the residential houses to commercial or industrial facilities, 98% of the time the main water source will be the municipal water scheme, where it comes from the reservoirs, is piped to your facility, and then enters your facility through one main point or sometimes multiple sources, and then is distributed around your facility via the piping network to each of the water usage points or operations. Now, what I mean by only entering a specific or several operations, in some instances, you may have inputs which are not distributed to all the water operations around your facility. For example, you may capture your rainwater off of your facility's roof. That water then, again, may be used on the irrigating your garden or for farm crops, things like that. So in that instance, there's a specific use which uses a different water input to what the traditional facility may use. Right, then we're going to have a look at what operations are. Operations are characterized by water entering a domain, an operation taking place, and water then leaving the domain in a similar or lower quality state. Some examples of operations would be, for example, a drinking fountain, a car wash area, an air conditioning unit, a toilet, a hand basin, a shower, a pool, jacuzzi. All those items use water in their daily operation. So hence, it is called an operation. So on a site, or whether it's a house or whether it's a commercial building, there may be multiple operations around the site which use water through their primary functions. What we mean by water leaving the domain in a similar or lower quality state, going back to the shower example, the water comes through the shower nozzle. It's come directly from the municipality and hence is of traditionally a high quality state. You then use it to wash yourself. The water then goes through the drain plug, except it's now got a bit of soap added to it and possibly a bit of dirt which has been washed off the person. So hence it is a lower quality state when it's leaving the operation than what it was when it entered. Moving on to outputs. Outputs. Water that has been used in operations for some process and is now either leaving the site audit domain or being redirected to another operation. So a lot of the time in residential to commercial facilities, including industrial facilities, once the water leaves a certain operation, a lot of the time it traditionally goes back straight out through the sewer and off to the municipal works for treatment. So in this instance, one of the main outputs for the facility would be the sewer. Some other examples, if you are a farm and you are irrigating your crops or you have a garden, some of the water leaving the irrigation system has two possible outputs. One being some of the water seeps through the ground into the groundwater tables or the aquifers beneath it, or another potential reason could be evaporation. Evaporation and groundwater are two other outputs other than the sewer. Now, if you're a facility that produces products using water, your product will also be an output of the water. So if you're producing, whether it's beer, whether it's a can of cool drink, that can of cool drink uses the water in its product itself and leaves the facility in the finalized product as an output. Then onto the domain. The domain is the boundary drawn around the water audit element. It's the boundary which encapsulates the previous three definitions which I mentioned, being the inputs, the operations, and the outputs. It traditionally is the boundary of the facility or site that is being audited, or in the instance of when you're looking at a specific operation, the boundary would then be the inputs to that operation, the operation itself, and the specific outputs of that operation. Then looking onto the water management process. Okay, we now understand how water enters our facility, we understand what an operation is, and we understand what an output is. Now, water management process is closing the loop between operation outputs to ideally reuse it as another or the same operation's input, usually via some intervention to improve quality of the output water. Back to the example of the shower, where it's the output of the shower is dirty water, well, in essence, a lower quality water than what it was when it entered the system. You can then go about capturing that water via a grey water system, which usually would have involve sedimentation tanks and maybe a couple filters to ensure that the water going from the grey water system to possibly your irrigation system is of a high quality, so it doesn't have any detrimental effects to the lawns you are using to irrigate. But another sidestep precaution you may need to take is that you may want to include biodegradable soaps, just to ensure that wherever the next water use is, where it's an input, for example on the irrigation side, that is a high enough quality not to have any detrimental effects. So that's what we call the water management process, linking certain outputs via some sort of intervention most of the time to an input of another operation. Then on to flow measurements. How do you actually go about quantifying flow around your facility? How do you actually quantify how much water is entering your facility and then it's being distributed to all the different operations around your facility, and then how much is actually leaving those operations to the various outputs around your facility? Now, as previously mentioned, one of the key points to the definition of a water audit is to quantify flow. Now, the pictures on this slide are just a few examples as to how an auditor may go about quantifying flow for the various water inputs, operations, and outputs. They are namely being inline flow meters, which is the picture in the bottom left, to ultrasonic flow meters, which is portable, picture on the top right, to questionnaires, or a symbol as a bucket and a stopwatch, which simply measures the volume of water, and where with a known volume you measure the time it takes to fill the bucket of water, and then you'll be able to measure the flow rate, for example, on a tap, how many liters per minute that faucet is running at. So again, back to the famous saying, you can't actually manage what you don't measure. You need to implement what we call a water management strategy. You need to have a good understanding of how much water is actually entering the system, being used up in the system, and then leaving the system. Then on to the importance of a water flow diagram. Now, ultimately, after completing an audit, you'll end up with what is called a water flow diagram. Now, water flow diagram is an important tool to help understand the basic layout of the water audit domain. It also helps you to ensure you have captured all inputs, operations, and outputs. It also enables physically complex systems to be simply represented in an interrelated manner. Now, having a look at this specific example, it shows you how the inputs relate to the operations and outputs. So in this example, the only input to this system is the municipality scheme water. It then represents that 3,000 kiloliters per year enters the entire system. Now, one way to know how much water actually enters the system per year is to analyze the monthly water bills. By adding up the monthly kiloliter consumption, that will give you the annual kiloliter consumption of the facility as a whole if there are no other water inputs available. From there, that 3,000 kiloliters per year is then distributed to all the different operations. In this instance, the operations are the drinking fountain, a shower, a sauna, toilet and hand basin, and air conditioning units. And each one of those will have a differing quantity of water flowing into each of those operations depending on the specific use. Then, as you can see, from leaving the operations, we've also quantified how much water leaves the operations and at the end of the day ends up back in the output, which in this instance, again, is the sewer. Now, it's not always going to be 100% a one-to-one relationship in terms of what goes into the operation, leaves the operation. If you have a look at the drinking fountain, for instance, 122 kiloliters per year enter the drinking fountain, yet only 20 kiloliters per year go back into the sewer. This is obviously because people have walked up to the drinking fountain, turned it on, and they've consumed some of the water themselves. So often it's not a one-to-one relationship, and anyone who performs a water audit needs to keep this in mind. As long as you can be 99% sure that you've accounted for the water leaving, you can then represent how much flow you can, whether it's by estimation or measurement, how much is actually going to the output, in this case being the sewer. Moving on to slide 13, the importance of water quality measurement. Now, water quality is determined by the presence of certain substances in the water. Now, ultimately, after completing an audit, you'd like to have measured water quality throughout the facility wherever possible.